Hey, the topic right now in math class is like, what does it mean to increase a number by a certain percent, or what does it mean to decrease a number by a certain percent, and how can we calculate by what percent a number is being increased or decreased in given situations? And there's this one like particular misconception that a lot of people have about what it means to increase a number by a certain percent or what it means to decrease, or maybe I should say like just a certain aspect of percent increase and decrease. Like a lot of people, if you ask them, they would get this particular question wrong. And I'm not going to tell you what that question is yet, but I think it'll be pretty clear after we do what would have been today's warm up if you were actually physically in my classroom today. And this particular misconception will explore a little bit more in the book and in another activity I'm going to ask you to do later this week. So the paper says, choose any number, literally any number. I want you to do this along with me too. Pick a different number than me. Like, so remember when we do this, when you're watching these videos, you're supposed to have like some piece of scratch paper that you're writing stuff on. You should have a writing utensil, and you're supposed to have a calculator, and so am I, and I'm failing right now because I don't have my calculator. So let me grab that real quick. There it is. All right. So I'm going to pick a relatively easy number. How about, I'm going to pick a super easy one, actually. 10. I know that 10 will make this activity pretty easy. You can pick a challenging number if you want, or a difficult number, but you pick literally any number you want and put it in box A. Ooh, wait, I should be careful because I know there's some smart alecks out there. This activity doesn't work if you pick the number 0. So pick a non-zero number, please. All right. Now it says decrease your number by 30%. You can do this easily by multiplying your number by 0.7. And then in parentheses it says, why does this work? And if we were in class, I would ask you to explain why it works or talk to your group table about it. But it works because 0.7 is 70%. And if you take away 30% of something, you get 70% of it. So this is a relatively easy calculation, but let's do it on the calculator anyway. 10 times 0.7, that's 7. So if I take the number 10 and I reduce it by 30%, I get 7. You should be doing the same thing to your number. All right, whatever number you chose, multiply it by 0.7 so that you're reducing it or decreasing it, whatever you want to say, by 30%. So you have your new, like, B number, I guess we could call it. And then it says, increase your number from box B. So for me, that's 7. For you, that's whatever number you have here. Increase it by 30%. You can do this easily by multiplying the number by 1.3. And it says, why does this work? And if we were in class, I'd ask you to explain or talk to your neighbors about it or whatever. But we can't do that. So it works because 1.3 is the same as 130%. And if you increase a number by 30%, that's what you get, right? You get the original 100% you started with and an additional 30%. So total, you want to have 130% of the number you started with. So I'm going to take my 7 and multiply it by 1.3 in order to increase it by 30%. And I get 9.1. And now it asks me, are the numbers in box A and C the same? And well, obviously they're not. I had a 10 and then I finished with a 9.1, so no. If you're following along with me in this, you shouldn't have the same number either. Whatever you started with in A should not be the same number as in C. And so the question says, did you expect the numbers from box A and box C to be the same or different, and why? Well, a lot of people would say that they would have expected the numbers to be the same. It seems kind of intuitive, right? If you start with a number and decrease by 30%, but then increase by 30%, it feels like you should get back to the same number, but you don't. And if we were in class, I would ask for you guys to explain it, and you would talk to your group tables about it, and we'd figure it out, but we can't do that. So I'm just going to tell you that it doesn't work because when you decrease 10 by 30%, you're taking 30% of 10. And then when you increase 7 by 30%, you're only getting 30% of 7, which is a smaller number. And so this never works. Anytime you're decreasing by a percent, you always wind up taking a bigger chunk than when you increase by that same percent, because whenever you decrease, you're starting with the bigger number and going down. And whenever you increase, you're starting with the smaller number and going up. So percent increases are kind of like always smaller than percent decreases if you're starting from the same number. All right, we'll talk about that a little bit later this week. So what do you say we just finished lesson 4? Because we've been super close to the end of this lesson from last week. So I'm just going to do the last question from it. And then I'm going to ask you to do the exit ticket and then check your answer from the exit ticket against mine. Remember, you don't have to take pictures of exit tickets that you're doing or like send them to me or anything. Everything we do in these videos is basically just for your practice, unless I say otherwise, because there is going to be something from a video later this week that I do want you to take a picture of and send me. So if I specifically ask you to, that's different. But normally, just do it, check it against mine, and then you're good. So the last question from lesson 4 says, Lou's math score on her achievement test in 7th grade was a 650, okay? 7th grade, she got a 650. And then her math teacher told her that her test level went up 25% from her 6th grade test score level. So what was Lou's test score level in 6th grade? Okay, so she did 25% better this year. And so thinking back to the warm-up we just did, an incorrect way to try to solve this problem would be to say, okay, well, what's 25% less than 650? That wouldn't work because you would be taking too big of a chunk away from 650, and you would arrive at an answer that's lower than the correct answer to this question. Because whatever her last year's score was, last year, I'll just write it like this. If you increase that by 25%, then you should get this year's score. But unfortunately, that wouldn't work the other way around. That doesn't mean that you can take this year's score and decrease it by 25% and get last year's score, because the percents don't work out that way. You would be taking a percent of a bigger number and it wouldn't work right. So instead, let's make a variable for the thing that we don't know. Let's call x last year. And then let's write an equation that matches the question. X times some number that I'll fill in a second equals 650. This is this year's score, right? So if we know what number that we're supposed to multiply last year's score by and put it here in this parentheses, then it should equal this year's score, and we're good. We just solved this equation. Well, if we want to increase a number by 25%, we don't want to do x times 0.25, because that would only get us 25% of this number. We want to increase it by 25%, which means we need the original 100% of the number and an additional 25%. And you can do that by multiplying it by 1.25, right? Because this is the same as 125%, right? These two things here are the same. So let's do that. Let's solve this equation. X times 1.25 has to equal 650. And we do that by just dividing both sides by 1.25. And so I'm going to grab the old handy dandy here, and I'm going to do 650 divided by 1.25, and we get 520. So last year her score must have been 520. And so just to show you what I'm talking about real quick, if you had tried the incorrect strategy of just reducing 650 by 25%, then I think you'll see that we're going to get a number less than 500. Our answer will turn out too low. So let's see here. If you reduce a number by 25%, right? Reducing by 25% is the same as having 75% left over, right? If you lose 25% of something, then you still have 75%. So an incorrect strategy for this question would have been to take 650 and multiply it by 0.75, 75%, because you're reducing it by 25% if you do it that way. If you try that, the answer you get is 487.5, because what you just did is you took away 25% of 650, when what you really wanted to do is find this number here, that when you tack on an extra 25% to it, you get 650. So I guess the point of the warm-up and this question that I'm trying to explain right now is that percent increases and decreases don't work the same back and forth. Increasing this number by 25% is not the same as decreasing this number by 25%. They don't play nicely like that. So you got to be really careful. All right, so I want you to try this exit ticket here. I've attached it to today's announcement. So go and pause the video, work on this question for a few minutes, and then check your answer against mine. Okay, so I'm assuming you're pausing the video right now. Okay, you should be back from a pause. So let's take a look at it. It says, Erin wants to raise her math grade to a 95 to improve her chances of winning a math scholarship. Her math average for the last marking period was an 81. Okay, so Erin decides she must raise her math average by 15% to meet her goal. Do you agree? Why or why not? Okay, so her current score I don't know why I wrote scores, but whatever, is an 81. And then she wants 95. So essentially we're trying to figure out how much do you have to increase an 81 by in order to get 95? Or in other words, 81 times some number that we're going to call x equals 95. And x is going to be the percent. It's not really going to be the percent increase. It's going to be a number that helps us to get the percent increase. What do I want to call this number? Let's see here. Let's call it the, this still isn't a very good name, but we're going to call it the percent multiplier. All right, and hopefully that'll make sense why I called it that when we're done. So what do we have to multiply 81 by in order to get 95? Well, in order to figure that out, you divide both sides by 81. And you get x equals 95 divided by 81. Everything that we're doing right now is kind of easier if you have it in a decimal. So let's just punch this into the calculator and see what we get. 95 divided by 81 is 1.1728, whatever, blah, blah, blah. I'm not going that far into it. I'm just going to use the 1.17. Okay, but if I convert that to a percent, that's 117%, right? So the reason I called this the percent multiplier is, I guess what I meant by that is that if you take 117% of 81, then you get 95. So if she needs 117% of her original number, that means she needs the whole original number, right? The original 100%, that's the original number, plus an additional 17% to get 95. And so the 17%, that's the percent increase, the additional 17. And so I would say that she is not correct. She said that she only needs to raise her score by 15%. And I'm saying, no, you need a 17% increase in order to go from an 81 to a 95. And so I would write, no, she is not correct. She needs a 17% increase. All right, my goal is to try to keep these videos a little bit shorter. We'll see if that actually happens, but it looks like today it's only 15 minutes, so that's good. All right, see ya.